Now let's talk about dependent events. So these are events in which the first event does affect the second event. For two dependent events, mathematically what we do is we still find the product of the probability of the first event and the probability that after the first event, the second event occurs. So we're still multiplying, but we have a new sort of notation here. So we have the probability that B happens assuming that A happened, okay? And we can write B after A like it's written here, or we can write B and then we can put this vertical line, and that denotes the same thing as after. So this is the probability that B happens given that A happened first. So let's do an example. We're actually going to do the same 6 green, 4 pink, and 6 brown marbles in a hat. We're going to pick 2 marbles from the hat, but this time when we take a marble out and we look at it, we don't put it back in the hat. Instead, we put it off to the side. It is no longer in the hat. It is not returned after we pick them out. So if the first marble is pink, so if we're trying to find the probability that the first marble is pink and the second marble is brown, the probability that we get a pink marble first times the probability that we get a brown marble given that we had originally picked out a pink one. And so the probability of picking a pink out is still the same. There's 4 pink marbles and there's 16 in the hat. However, now picking out a brown marble, given that a pink one was picked first and not put back in the hat, there are 6 brown marbles in the hat, but how many marbles are really in the hat now? We took one out. There aren't 16 marbles in the hat anymore. Now there are only 15 marbles in the hat. Okay, so we multiply these together. Again, this can be reduced to 1/4. If we divide by 3, we get 2 over 5. And so this is 2 over 20, which reduces to 1 over 10, which is 0.1 or 10%. So these are all the ways I could write that answer. And I am just double checking my answer. Is always a good idea to double check your answer. So I use my calculator and it is indeed 1/10. Okay. So that's how dependent events work. So let's do one more example here. We have 3 girls and 2 boys volunteer to represent their class at a school assembly. The teacher selects one name and then another from the bag containing the 5 students' names. What is the probability that both representatives will be girls? Okay, so we know there are 3 girls and 2 boy names in this bag. Okay, so the probability, we're trying to find the probability that we find a girl or that we pick a girl and a girl. Okay, that's going to be equal to the probability that we pick a girl times the probability that we pick a girl given that we picked a girl the first time. So the probability that I'm going to pick a girl out of the hat, well, there's 3 girls' names in the hats. There's only 5 names altogether. But when I pick this first girl out of the hat, I don't want to pick her twice. I can't pick the same person twice as a volunteer. I need 2 different people. And so once I pick her out of the hat, there are only 4 names left in the hat. So there are only 4 names left in the hat. How many of those names are girls, given that I already picked 1 girl out of the hat, or out of the bag? So now there are only 2 girl names left out of the 4 names that are left. And so the probability here is 6 over 20 which reduces to 3/10 if we divide by 2. So that is 0.3 or 30%. So this is the probability. These are all valid probability answers. Okay, so that is the probability that I pick a girl's name out of the hat. So hopefully you're understanding that this second number changes depending on what the first number was. So there are only 4 names left in the hat because I picked one out, and there are only 2 girl names left in the hat because I picked one of those out the first turn. So using the same example again, 3 girls, 2 boys volunteering, what is the probability that I pick a boy's name out and then a girl's name out? So we want to know the probability that I pick a boy's name out and then a girl. So that's written here, right here. So this is equal to the probability of picking a boy times the probability of picking a girl, given that I picked a boy the first time. So the probability that I pick a boy's name out of this bag is there are 2 boy names out of the 5 students. And then to pick a girl next, given that I picked a boy's name out, again, I picked a name out of the bag, I didn't put it back. So there are only 4 names left in the hat. Okay? How many of those are girls? Well, I didn't pick a girl the first time, so there should still be 3 girl names in the hat. So when I multiply these together, by multiplying across, I get 6/20, which again is 3/10, which is 0.3, which is 30%. So all of these are correct answers, and it turns out that it's the same probability of picking a boy and a girl as it is to pick 2 girls. So I want you to pause the video, and I want you to try and find the probability using the same information that we pick a boy and another boy. I know this isn't on your guided notes, but I want you to try it anyway. So pause the video, and when you're ready, come back and I will do the answer. All right, I hope you're ready. So the probability of picking a boy and then another boy is the probability of picking a boy times the probability of picking a boy, given I already picked the boy's name out. So the probability of picking a boy, there are 2 boys out of the 5 names. And then, if I picked a boy the first time, now there's only 1 name left in the hat that's a boy, and there are only 4 names left. So in this case, when I multiply across, I get 2 out of 20, which is 1 out of 10, which is 0.1 or 10%. So these are all valid answers. And there is a much less chance that you're going to pick 2 boys' names out of this bag than you would pick 2 girl names or a girl and a boy.